All right, here we go. Here's our first proof. It's number 25. And let's see what we can do here. I wrote everything out already. And let's take a look at the given. The first thing I do is you look at the given, and then you just mark it on your picture, if it can be marked, all right? Sometimes you can, sometimes you really can't. But if it can, I mark it on the picture. It says angle 1 is equal to angle 3, so that's easy to mark. Just put a little arc right here, a little arc right there. All right, so 1's equal to 3, and then I can visually look at the picture and I can see what's equal to what. I don't just have to try to remember. It says AC is parallel to BD. Well, AC is this one that's going up and down right here, so we show it's parallel by putting a little arrow to BD. We put an arrow on this one as well. All right, just darken it in a little bit. All right, and what are we trying to prove? We're trying to prove that AB, this top one, and CD, this bottom one, are parallel to each other. Well, let's think a little bit about what's going on here. In order to prove that two lines are parallel to each other, we've got several different ways. In fact, I can think of 4 different ways, 4 potential ways to prove that lines are parallel. We just had a whole lesson on that, didn't we? We're actually in that same lesson, but we talked about it before. So how did we show, or how did we prove that lines are parallel? If you could show what?
That the alternate interior angles are
Yep. That's right. If you have 2 lines cut by a transversal, and if you can show that the alternate interior angles are congruent or equal to each other, then guess what's true about those 2 lines? They're parallel. What's another way? If you can show the corresponding angles, right? If the corresponding angles are equal to each other, then the lines are parallel. If the what? Alternate exterior angles, right? If you can show the alternate exterior angles are equal to each other, then the lines are parallel. There's another one. It's not an equality. Right, if you can show the consecutive interior angles, what to each other? Supplementary. Not equal, but supplementary. Then the lines are what? Parallel. So we have those 4 ways right now in order to show lines parallel to each other. So you're trying to prove that this top line and this bottom line are parallel to each other. And we have a transversal, don't we? In fact, we have how many? 2 transversals. I got one right here and I got one right here. But since they gave this as an angle 2, don't you think you'll probably use this one? All right, yeah. So you probably. So let's think about this. If I can show, right, big if I can show that angle 1 is equal to angle 2, then what's the relationship between 1 and 2? What are they? What's the name of that relationship? They are what? Alternate interior angles, okay? If I can show that 1 and 2 are equal to each other, see? 2 lines cut by transversal, and if the alternate interior angles are congruent or equal to each other, what must be true about those 2 lines? They must be parallel. So that's the deal. I want to try, that's my goal, is try to show that angle 1 is equal to angle 2. I can't say it right now, right, unless they told me or something else. But there's some other things, there's a way that we can figure out that 1 and 2 are equal to each other. And that's what we're going to try to do. Does that make any sense? Alright, so if I can show that 1 and 2 are equal, then I can say the lines are parallel. So let's start with what they gave us. They say that 1 and 3. Look, I haven't even drawn my 2 columns, haven't even started writing out statements, reasons, haven't done anything on my proof, have I? I got to think through it. Remember we talked about the road map yesterday? Alright, know where you're going first before you get on the road. Alright, so I'm not writing yet. So let's see what we got. We got 1's equal to 3, don't we? And I know these 2 lines are parallel to each other. So why? Give me a reason. Why is 1 equal to 3? They told us. Give me a better word than that in my proof. Given. We just write given, okay? They told us, and that's true, but in the proof we're going to write given. So 1's equal to 3. Now let's think of what else might be true about 3. Look at 3 and look at 2. Allie, what do you think? 3 and 2 are supplementary? I don't know. Gabby? They're corresponding angles, aren't they? Do you see 3 and 2? They're corresponding angles. Now look what I have. I'm given that this side and this side are parallel to each other. So if 2 lines are parallel to each other, what must be true about the corresponding angles? They got to be equal to each other. So 3 and 2 are, guess what? Are equal and congruent. So if that has 1 arc, guess how many this is going to have? Just 1 arc. You follow me? Alright, so guess what must be true about 1 and 2 now? They must be congruent, okay? So watch. 1 equals 3. 3 equals 2. So guess what? 1 equals 2. You get it? Do you remember the reason for that? Transitive, right, transitive property. Well, it is a substitution. If you wrote substitution, you wouldn't be wrong, but it works real nice and slick if you go transitive, because 1 equals 3, 3 equals 2, so 1 equals 2. And there you go. If 1's equal to 2, They're alternate interior angles. Guess what must be true about this line and this line? They must be what? They must be parallel to each other, and that's our proof. Okay? We thought it through first, didn't we? We sat there, we talked about it, we marked up our picture, we kind of gave reasons for everything, and now we can actually go ahead and start writing out our formal proof. All right, so let's do that. Let's put a little 2-column proof together, just like this. What was the first column? Statements. And then the second column, reasons. All right, where do we start? Now, I'd say most of the time you start with a given. You don't always have to put the given in that correct order. In this case, it works out really well if we do put that first. Okay, so angle 1 is equal to angle 3. Why is that true? It's given. All right, that's easy. Now watch. 1's equal to 3. Then we want to go 3 equals 2. But I can't say 3 equals 2 right away, can I? What do I have to say first before I can say 3 equals 2? Well, I got to say something. What must be true about these two lines before I can say, yeah. What must be true about these two lines before I can say 3 is equal to 2? The lines got to be parallel. And they are. How do I know they're parallel? It's given. So AC is parallel to BD. Line segments, put the line segment over time. And that's part of the given. Okay, that just all goes together. You good with that? All right. Now look. I've got 1 is equal to 3. Now I know these are parallel. Now I can say what about 3 and 2? Now I can say they're equal. We've got to have a reason, though. What's the reason? That's right. Corresponding angles are what? Are equal or congruent. Right. Now, technically, the long version would be if two parallel lines are cut by a transversal, then what? The corresponding angles are congruent. Do you want to write all that stuff out? I don't either. Okay, so I'm letting you just shorthand it a little bit and just say corresponding angles are congruent. But you got to realize it first started off, you had to know that your lines are parallel first. Make sense? So the parallel thing right here has to go before 3 is equal to 2. You got to make sure that that goes before this right here. All right? So now look what we got. I've got 1 is equal to 3. 3 is equal to 2. What did we say earlier? That means 1 is equal to 2. And what reason do we give for that? Transitive property. And that was covered in chapter 2. I know we skipped it, but the stuff that we need, hopefully I'll let you know what it is as we get to it. All right. So there you go. Oh, do you remember yesterday we talked about that thing when I said if one angle is supplementary, or if two different angles are supplementary of the same angle, then they're equal? That was actually in chapter 2. I looked it up. It was like chapter 2, section 7 or something like that. Okay. Maybe if we have time at the end of class, I'll show you where I got that from. But that actually was from chapter 2. All right. I may actually go back. I don't know when, but maybe at some point I might go back to chapter 2 and just do 1 or 2 lessons, not the whole entire chapter, but just look at a few things anyway. All right. So anyway, what do we got? We got 1 and 2. So if 1 and 2 are equal, hey, we're there. We're home free now. What is it? If 1 and 2 are equal, what must be true about these two lines? They got to be parallel to each other. So now I can say that AB is parallel to CD. And what would be my reason for that? No, what's 1 and 2? Look at my step before this. 1 and 2 are equal to each other. They're not corresponding. What are they, Taylor? They're alternate interior angles. So we write alternate interior angles are equal. Now again, I shorthand this big time, but technically it's actually the converse of the alternate interior angles, because what does it say? If two lines are cut by a transversal and the corresponding or the alternate interior angles are equal, then what's true about the lines? Then they are what? They're parallel to each other. So I took all that wordy stuff, and I shorthanded it just into this, okay? So that's basically the converse of the alternate interior angle theorem. I just write alternate interior angles are equal, right? If those are equal, then these are parallel. That's good enough for me, all right? Just to have an idea what's going on. And that's it. That's your proof. You're done. All right? What do you think? That wasn't too bad, was it? Starting to make a little bit of sense now? Okay. Did you guys do proofs at all at home? You didn't do any proofs? This is your first time seeing this? Okay. Yeah, usually you don't do it until you get to geometry. And just wanted to see if you guys did that or not. All right, let's, I tell you what, 27, what was that? That was 25, right? 26 is really, really close to that. I'll let you just look at try 26 on your own, okay? It's very, very similar to this, so use what we learned from this to do 26, all right? Let's go to, actually, let's skip to 28, and then we'll go to 27 if we have time, all right? All right, all right, here we go. Here's, this is number what, 20, what did I say? 8. Okay, so we skipped to 28. Let's write down the given on our picture. 1 and 2 are equal. There's 1 and there's 2. It also says that LJ, line segment LJ, is perpendicular to ML. Here's LJ right here, and here's ML right here. They're perpendicular. So what kind of an angle do they form if they're perpendicular? 90-degree angle. So I put a little box right there. Everybody good with that? All right, we want to prove that KM, this right side, see LM is already perpendicular to ML, isn't it? What we want to do now is prove that KM is perpendicular to the same line, ML or LM. Everybody got that? Now, we actually had a theorem. It was like in section 3.2 or something like that. It was the last thing we talked about. We haven't talked about it a whole lot, but if you remember, it kind of looked like this. We had two lines, and we had a transversal, and we said if these two lines are parallel to each other, and if that transversal was perpendicular to the first one, guess what? It's going to be perpendicular to the second one as well. Do you remember that? Okay. That's what we're going to use right here. They actually gave a name for this. I didn't tell you to memorize it, but I'll tell you what it is. It's called the perpendicular transversal theorem. I'll just shorthand it. THM. Okay. Perpendicular transversal theorem. All right. That's what it says. So if you have two parallel lines, you got to start with parallel lines, and one line is perpendicular to the first line, parallel line, then it has to be perpendicular to the second parallel line. That's basically what that thing says. Does it make sense? Okay. Do we have that situation here?
Yes.
Well, I don't know any parallel lines. They didn't tell me anything was parallel. They didn't put it on the picture. Do I know any parallel lines? Yeah, that's right. Exactly right. You can show that you do have parallel lines because you actually do. Because if I told you that 1 and 2 are equal, what's the relationship? What's the words? They're alternate interior angles. What are my two lines then? JL and KM. So they have to be parallel to each other, don't they? Because if the alternate interior angles are equal, then the lines are parallel. Well, the alternate interior angles are equal, right? So guess what? This line is parallel to this. Now check this out. This line right here is perpendicular. I'm sorry. Yeah, LM. Let's look at LM. See, it's kind of like we took this and turned it on its side. You see it? So LM is perpendicular to JL because they told us. And we're trying to prove that ML or LM is perpendicular to this. Well, if it's perpendicular to one parallel line, then guess what? It's got to be perpendicular to the other parallel line. Why? Because of the what? Perpendicular transversal theorem. Okay? You follow me? Does it make any sense? So we have that situation, don't we? And let's just write it out. Make it look nice and neat. So we've pretty much talked about everything. Whoops. So what do we got? We got 1 is equal to 2, right? Now, why did we even care that 1 is equal to 2? Just so we could say what? That those two lines are parallel, right? So we need to show those two lines are parallel. We already know that this ML is perpendicular to this line, so that means if it's perpendicular to one parallel line, it's got to be perpendicular to the other parallel line, and that's what we're trying to prove, isn't it? All right, so let's draw this out real quick because I'm running short on my video time. We'll just call this statements and reasons. Is that all right? You write the word statements and reasons. I'll just write it like this. All right, first thing, I said that 1's equal to 2. Why is 1 equal to 2? It's given. All right. Now watch what I did. You could put the next given next, but watch. If 1's equal to 2, what does that mean? Forget the perpendicular thing. If 1's equal to 2, then guess what that means then? JL is what? Is parallel to KM. So doesn't that make more sense if I put that right after it? Yeah, if 1's equal to 2, then what follows from that? That JL, or I tell you what, let's write JL. Is that all right? JL is what? Parallel to KM. All right? And I'll tell you what, I'm going to pause this and write it down because I'm running out of time. All right, here's our whole proof just because we're running out of time. These two lines are parallel because alternate interior angles. We were given that these two are perpendicular. Just if this is perpendicular to one parallel line, it's got to be perpendicular to the other parallel line. And there's our proof. And there's our reason right there. And we're good to go. Bye.